All right, so we're gonna backtrack just for a second. We got a little bit ahead of you guys. Tell you what we did. I know, so you notice we got case savers in here. We got studs in here. If you have a single port, a 1600 motor, and you're trying to put it into a dual port, so let's say you started out with a single port, you can use the 40 horse studs in the middle, and that gets the right length. Or you can just have all dual port. If you have all the dual port studs, that'll be correct as well. But we used, on this one, we had a set of single port. We didn't have any dual port ones. We had a set of single port ones, 10 millimeter studs, and we put in the top ones were from a 40 horse motor that we had laying around for years. So you notice we put these in with red Loctite, and then after we put them in with red Loctite, these case savers, then what we did is then you take that brown stuff here and you coat it on the outside. On the threads, so, and then put that in afterwards, because these go all the way through, and because they go all the way through, they could leak out of that area. So you need to make sure you put on the case savers, you want to have the red Loctite, and on the studs you want this stuff here on the studs to make sure it doesn't leak. You know, I noticed I got some comments about there might be somebody who says, did we check everything as we put it together? Now, you know, check before we put it together. Did we check all the tolerances to make sure everything's been machined correctly? You know, that is your job as an engine builder. You're supposed to make sure that, you know, the machinist did their work right. Now, there's a lot of different ways to do that. You know, when you've done a lot of motors, that's why this is not like your average Joe Blow bolted together and run it motor. You know, this stuff, you know, these are chromoly. The original was not chromoly; it was the German steel. It was German forged, and it's a chromoly crank. You know, this is an aluminum case. This is all not original parts, so the original specs are not exactly going to be the same. So if you go with just original specs and then you say, oh well, this is out of spec, then you know you might be wrong. So the best way we found to do it is go by feel. Is when you're putting it together. If the rod goes on tight, then you know there's a problem. You know, if the rod goes on tight, you know there's a problem. When you tighten, you know, you do your test tighten on your case halves, and you start to tighten it down slowly, and you know that it affects the way it's turning, then you know there's a problem. There's something not right. Then you take it apart and you have to look for that. Then you start to get your measuring stuff out and then start checking things. That's what we found. You know, after building, you know, hundreds of engines, you get better at that, and you get to know when something isn't right by feel. So some of you guys say, hey, you know, plastic gauge, if you want to use that, go for it. You know, I'm not saying not do it, but I'm just saying that, you know, your tolerances are probably going to be different than the original ones. So if you're looking at your rod, you know, the way your rod goes into the crank, stuff like that, and you're measuring those tolerances with measuring tools, you might find that the tolerances are going to be slightly different than the original. Like I said, by feel is our best bet. It's the best way we've done it for years, and we've never had motors that frag. I mean, I'm not going to say we never do. Everybody does from occasion, but I'm marginally correct most of the time. We don't have a problem. It's very, very rare. So anyway, this is, like I said, this is not this shouldn't be your first engine build. If your first engine build is one of these, it's going to be a little bit, you know, a little bit of a learning curve, and you don't want to learn on something like this. If you make a mistake, it's kind of an expensive motor to lose, you know, if you mess up. Well, it's, you know, the parts are. You probably won't mess up the case. That'd be really bad if you did. You'd have to do something very wrong to do that. So anyway, we'll move forward here. We're going to do now. We kind of mocked up our in-play once. We checked it, and we found out that these are the types of things you're going to run into. Like the crankshaft on these, on the one we got was slightly different, or the flywheel here may have not been machined exactly the same, and it was about 10 thousandths. It had about 10 thousandths too thick. Either you could machine off the crank, which we weren't going to take it all apart, or we could take 10 thousandths off of here, because we were going to end up having to use 4 shims on the back, and the Volkswagen requires 3 shims. So, and we were going to be into a really thick tolerance. So if we went ahead and had 10 thousandths taken off of here, out of the inside of here, that was going to tighten things up enough to where we could use a reasonable amount of shims. and put it together. So we're going to go ahead and run in play now. We'll show you how that works. Okay, you always want to make sure you lube your threads on your nut and on where it goes in the crankshaft, because you're going to take, especially these chromoly ones, they're so hard that you're going to be taking them on and off a few times, and you can damage the threads if you don't do that. So one of the things you need to do is these have, if you see how these are here, I don't know if I can get it to focus. There's one of them has a wider gap, and what we do is we mark that one, and then we mark the flywheel with the same one so that it's easier for us to put on. Go ahead and put it on. And then he marks here on the flywheel, if you mark on the flywheel, so that every time you measure it, you're going to be measuring at the same place, because there always is just a very slight amount of run out on that flywheel. And so with that, we're going to go ahead and run it down with a gun, tighten it. Some of you guys aren't going to have this fancy gauge set up here, and you can buy these little in-play tools. You can use it. What this is, as it bolts in place of this, okay, and then you use a feeler gauge between here and the flywheel, and that also works well too. So if you guys don't have a in-play tool that maybe you're not going to be able to afford something this fancy, these are available also at like Crankshaft. Some of the Volkswagen parts places have them. Yeah, if you really want to get creative, you can buy one of these. Go to Harbor Freight Tools. They have those dial indicators, and you can actually put it on this. You can find a way to asphyxiate it onto this, and that actually works well too. So what's our base here? Go ahead and pull it out. We got it at 0, and he pulls it out. You got 36 thousandths. Yeah. So what we've got to do is we got to come up with, we want to have between 3 and 5, right? 3 and 5?
3 and 5.
All right, so we want about between 3 and 5, and 3 and 5 thousandths. So I'm trying to get back on autofocus. 3 and 5 thousandths. So you need to do the math real quick and make sure you come up with the right amount of shim stacking, and we'll put it together and double check it. All right, so we've got 3 shims. You want to have it so you measure 3 shims, and what we do is just stack them up and measure them with a micrometer. You're going to need one of those if you're building a motor. They have them, of course, at Harbor Freight Tools, and some of them work pretty good. I'm not going to say that they're perfect, but they can get the job done. And then going to go ahead and put the flywheel back on. We know where it's marked. We marked the same one. Going to go ahead and put the nut back on afterwards, and we're going to tighten it up and recheck it right now. Sometimes you have these things apart 3 to 5 times. You just don't know. So don't expect it just to go together the next time you do it. All right, so we've checked it. We've pushed it in and out. We know we have 4 thousandths. You guys are skeptics.
4.5.
Yeah, 4.5. We're gonna probably fine right there, and we're going to go ahead and move ahead with that and start putting the crankshaft seal on. We'll show you that. So we've STP'd up these things here, the shims. We've cleaned this out here. Make sure you get all the oil out of there. Remember, I told you to oil it before earlier. That's just when you're assembling it, taking it back and forth. But when you go to put it together, you want to make sure it's clean and dry. And then we actually took some sandpaper and kind of smooth this out. What was that? 1200? Some 1200, and just smooth out some of the brand new. Feel them, they're kind of rough. And here we just smooth that out so that it's really polished for the seal. We don't want the seal to get ruined. That's a key thing. So if you notice, there's not that stock gasket on here. That's not required with the stoker crank and 8 dowel. We do have the O-ring in here. We took some silicone and just a light little coat of silicone on there just to kind of make sure it's sealed. The seal surface oiled around here and on the face of that. Now, if you're using a used flywheel, a lot of times the seal will rub a groove into here, and a lot of times if that groove doesn't either it has to meet up exactly with the new seal or be completely in a different place. If it's just kind of halfway in it, the new seal will leak. So if you've ever got a leak on your flywheel, it might be because of that. Sometimes it's just a good idea just to put a brand new flywheel because of that reason. We've even taken this existing seal and pushed it back further to make sure it's not on that same part of the seal. Alright, so after that, go ahead and put some Loctite on your threads here, and then a little bit of silicone over the dowel pins. Sometimes they leak between that washer and the back there. It's this part of the video is really important to watch. This is when you need to really know you look at your specs for the gland that you're using and the flywheel you have. You know, if you're using Cormolly flywheel or a regular flywheel, look up some specs on that, get the right one. We've already torqued ours. We're not going to give you our spec, but ours is together, and we also got some grease on these needle bearings. Definitely put that on there before you put the motor in the car. So we always drop our distributor drive after, because if we drop it before, it can fool with you when you're doing your in play. Some guys say, well, you do it before. It's preference. You can do it now. This is when it was normally done whenever I've built a motor. And so we're going to go ahead and drop it. One of the things you do is you put it in upside down first. Okay? And what that does is that's going to tell you if it's going to get stuck. If you ever had one get stuck in there, you know, it's a pain, because you might have to lift it back out and then go. Alright, so we just drop this thing or something in there to center it, drop the washer in, and use that to center it. We also have some STP on that washer to kind of hold it in place. It's kind of sticky stuff. So then it's down in there, already in the right place. It's a real pain if that falls in. I've had it happen before once. So I realized it was pretty hard to see how the distributor was dropped in here. And this is how you do this. If you have a type 1, you know, type 1 and type 2, it goes in like this. So that's the wider part here and the narrower part on this side. So it kind of lines up with the fuel pump like that. And then if you have a type 3, then it's supposed to be like to the edge of the second cylinder over. Second cylinder, number 2. So, you know, I don't know, I guess lines up with that stud. So just keep that in mind, you know, that's how it's supposed to be done. You couldn't see it, so I wanted to make sure you guys could see it. Also, another thing I'm going to talk about real quick. So another thing I was going to talk about real quick is we didn't get on camera is, of course, we did check the pistons, take them apart, clean them, and we also checked the ring gaps. You know, we just run through the piston and just make sure there's nothing weird. And we also set the rings. So, but the way we set the rings might be different than the way that you guys do it. We always suggest that you get a typical Volkswagen manual, like the one I just showed in the video, and use that as reference for a lot of those little things. This is mainly, you know, a difference between a regular motor and a stroker motor. And like I said, you know, a lot of it's by feel, because the actual torque specs are going to be different depending on what parts you get for your motor. So, stuff like that. So you always drop, you know, we just have a random junk distributor. This one's not even put together right. And we just put it in place just to hold the drive down in place, because if you don't have it down in there, then when you go to turn it, it'll ruin that brass gear down there. Keep that in mind. These are pretty cool pistons. They're shortened skirts. They got this, whatever it is. What is that black stuff called? I forget. But they're actually really nice. These AAs are, and they work really good. Okay, then you set your rings however you want. You can go to the book for that, for the way to do it. We have our own way to do it, but then the book has its way, so I'm not going to argue. But then these clips, if you notice, they're kind of arced feeling. If you can feel it in your hands, you want them to, let's see, trying to explain this, have the arced part outward, or no, arced part inward. So that, okay, so this one's arced this way, so that the edge is a sharper edge that's on that clip. You can feel them in your hand. You can feel, and there's a sharper edge so that it doesn't want to pop out. If you put it this way where it's kind of arced, it's arced like this, okay? If you have it like an arced like that, then these can actually pop out of place. So on a performance engine, you want it to be so that the it wants to go in instead of out. I don't know, it kind of makes sense when you have it in your hand. So we got the one piston on. The end plate we've already checked. I'll tell you about that in a second. By the way, we did take these all apart and actually clean pistons. Some guys actually sand the edge of the piston. I was talking to some of the racers about that. They just said that's mainly to lower your CC limit. But it's really not necessary. We've been running them like this and never had a problem. These are not sanding them.
Yeah, these are already beveled.
These are already beveled. If you look at these are already done. So they're actually done really nice. Some guys like to sand that and make it rounded. You know, that's not really 100% necessary. The arrow pointed towards the flywheel. We'll go ahead and slide that barrel on. Let me get it. And get one hand free here. He's got it. Better if I just let him do it. Slide them on. It's nice. Yeah, these little ring compressors, the Volkswagen specific ones are nice. I've even done it with the other style ones. There's another one, and we also have silicone on the barrel if you just thought that squirt out. And you would have your cylinder shims on if you had any. We did check our end plate or our deck height, and I'll just give you what this is what I found out from other guys that build these things all the time. What our old school stuff was, and again, this is a stroker engine, so you might have a little bit different type of opinions on this stuff. But a deck height, from what the original specs were, was typically 60 thousandths was a good deck height, and we're right at 58 thousandths on this motor. So we didn't need to have shims. Typically, if you can get more of your fire to fire in the cylinder head than in the barrel, that's going to reduce your detonation. So some guys are even, you know, running their pistons all the way up tight, and then they're putting in like a head gasket around the head. So from what I understand, the lowest you should have on a street motor is 45. Okay, the lowest, and that's really, really tight. So 45 is the lowest. I wouldn't even get near that number. But 50 to 50, between 50 and 60 is okay. Even if you wanted to go up a little bit higher than that, some guys are going, and they say up to 70 thousandths is a good deck height. I've even seen guys put together with 90 thousandths deck height. But again, if you're getting too much fire in your barrel and not in your cylinder head, you're not doing yourself any favors. Having more fire in that cylinder head is going to be your friend. It's going to be less stuff. So on our old motors back years ago, when we were running them low compression, we were selling a lot of motors in the shop I worked at. They would step cut this, so they would cut they would leave like about 1/8 of an inch or less around the edge of the barrel, and they would step cut another cut in here to make the combustion chambers bigger, because we wanted to keep them without having cylinder shims and then still having more fire in the head. So it's a little game you play. Again, you can do that at your own risk and your own reference. And if you don't like my data, you know, you can comment that, and you can use it or not use it. It's all up to you. So carefully tap them in. Of course, you know, you got the pin. This side's going to have the clip on it so that you can push that pin in place.
Make sure it's on there.
And make sure that it's on there good. And make sure that the clips are all on. You can't spend enough time. You can't spend too much time getting the clips on. You just make sure they are right. That they are on, seated all the way around. You do not want your piston clips to fall off. So I'm going to bring you guys back in the video in a minute. We're going to go ahead and assemble this whole top end, get it all ready for the heads. We'll put those on, bring you back in a minute. There's no sense in you watching me do every piston. It's basically repetitive, the same thing on both sides. All right, Chris said I did something wrong. What's wrong with this picture? Oh, yeah. I think I know what's wrong. What do you guys think? What's wrong with that? I was putting this one on, and he says it's not right. Okay. Alright, so I'm going to show you guys about the pressure relief stuff. This is how this is assembled here. And if you get one of these kits, you know, the pressure relief kits, you know, that has this kind of piston here, versus the original ones were just 2 of these, I believe, something like that. You're going to be short one washer, so make sure you have one of the original washers and the plugs, because if you buy the new block, they do not come with this, any of this stuff. So we're going to go ahead and put these in. Let's check it out. Assembly lube. Alright, then you drop that one in. So that one goes in the rear of the block towards the rear of the car. This one goes in the front, like that.
I put oil in the holes already.
There's already oil in the holes. They're already lubed. If you didn't hear him say that. He drops them in place. I mean, sometimes you get these old ones. Some of the old cases you'll have like burred up and stuff. That's why it's so nice. These new aluminum cases are very well made, and you know, haven't had too many problems with that stuff. So then you put the tall spring in the back of the engine, shorter spring in the front. And if you want to look up on like there's a websites out there that show how what they actually do, and it's something about, you know, not giving all the oil to the oil cooler when it's cold, giving more to the engine, and then as it warms up, it starts to put more through the oil cooler. So that's what the design is, I believe. That's what if I remember right. But you know, you might want to check out one of those charts if you're curious about that. You can use a hammer and chisel to tighten that up if you want. See how he's doing here?
Not too hard, just enough.
Just enough. This is an aluminum case, so it's going to be a little bit stronger than a mag. If you did mag, you better not do it that tight.
That's my favorite one right here.
And this one's always fun with the long spring-a-ling-a-ling.
It's more fun you're doing underneath the car.
It's really fun, yeah. When you're doing it underneath the car, don't you love that?
It's my favorite.
God, man. Oh, there it goes. Oh.
Man, we lost this spring.
Boom. Maybe did it hit the ceiling?
I don't know where it went.
I think it went over here. You guys see it? I don't see it.
It's in the scrap pile.
Oh, I heard it hit the ground. Oh, here's the spring. Ta-da!
There it is.
There's the spring. I thought he lost the cap too, but just the spring. So it's kind of a little hard to do. Sometimes you can like put a socket on the end of there and just kind of use it to hold it. I've done that before. Like just use this, you know, use a socket and just let the teeth of the socket kind of hold it. But these things are a pain, especially with these new springs. They're really stiff. Yeah, let's lock down the engine stand. We did put the heads on just temporarily because we may not get to our push rods today, so we didn't want our glue to set up without having some tension on it. So, little trick there.
There we go.
All right. So we got these in here. There's a lot of extra stuff we're putting on this motor. We're going to have to pull this. We forgot to long stud this, so we're going to have to. We have a special wrench to get that off. Put a long stud there for the extra deep sump. And what's kind of cool, we might be figuring, we don't know yet. We're going to check this out, but we'll probably bring you guys back in the video once we figure it out. Because there's a lot of figuring on your push rods. So we got the cut to fit ones because sometimes you end up with odd, you know, deck height stuff, and you end up with a lot of shims. And since we ended up with no shims, I'm thinking that we'll end up with, so these are 5.4 rods we got in here, 5.4s. So since we put the 5.4s on, it kind of compensated just enough and made up for the stroke and made it so it was, so that we just have to put no shims in this. So that's not very often. This is kind of a nice little motor combination. If you're building one of these and you get all those same parts, you might be pretty close to that. That would be kind of cool, you know, with these heads. The CCs, we did CC these. We're going to show that in a little while. We're going to come back into that. But we did CC these already, and we're going to be, we figure, based on the CCs and the deck height, at about 8 1/4 to 1, which is perfect for the camshaft and everything we got in here. What I was going to say is, so we put these on here temporarily. What we were thinking would be like kind of neat is we might end up with stock pushrod length, because one of the things that's a pain when you build a stroker engine is the shortening of the pushrods or lengthening the pushrods. Usually it's lengthening, and it's kind of a pain to do. So we're going to try a stock pushrod in here and see if it works, kind of mock it up, and then we're going to put on these cool tin things. So we're going to have a video on just putting on the cool tin, so you guys will know how to do it the quote unquote right way. Because one guy says, oh, if you don't do it the quote unquote right way, then there's no point in putting them on. It's like, well, who would do it the wrong way? Okay. Well, anyway, we'll bring you back to the video in a little bit. Okay, so we did our mock-up of the Valvetrain, and we were thinking we could go with stock pushrods, but we can't. So I'm going to explain to you guys a little bit about how that you do this. We're using a dial indicator, and you know, the best way to use it is to put the dial indicator, because what we're going to do is we have to find the middle of, so because we have a performance cam, and this is something you always have to do with a larger performance cam. This, you know, a really mild one may not be that much difference, but you should always check this. So the height right here of your rocker arm assembly in the length of your push rod may need to be adjusted. So what you want is when it is right in the middle of, so when the valve is not depressed at all, and when it's fully depressed, you need to determine what the middle of that is. So what we do is we use the dial indicator, and then we rotate the engine over. We already know what the number is. Ours is, so it goes down. You watch how many times it goes around. So it goes around once, 2, 3, 4, and then you'll see it start to come back up. So then right there, that's the bottom, okay? So then we go halfway. So when it's 4 and what, 20?
Yeah, we'll say 420.
420. So right at 210. So we'll set it up at 210. We'll go right to 210. And that's the middle. $210. Okay, you could get one of these little dial indicators at Harbor Freight and maybe make a little mock-up if you want. It's not hard to do.
It's 220.
And 220, so 220. Yeah, so it was 240 before, right? And so at 220, this thing should be a perfectly straight line down the valve, and right there is where it's a straight line. You see? So what we have to do is we have to space this thing up enough, and then make up push rods the right length, so that this thing is a nice straight line in this between the fully depressed valve and the fully released valve. Okay, so it should be a straight line just like that, and it's not. It's actually kind of at an angle. So that's what you need to look at. We're about right here. Okay, if you can see, it's not a straight line. It looks like a, okay, it looks like that. Okay, so we have to make our Valvetrain by raising this with a bunch of shims. Okay, so it's the right length, and then make our push rods to fit accordingly. So this is where it becomes a little bit, challenging if you're a brand new motor builder. You can't just bolt parts on. You got to go through and check all this stuff. And so we got these. They have these two different types of push rods. They have these ones that are adjustable push rods like this. These are chromoly too, right? Yeah. Yeah, these are chromoly. And these are adjustable push rods.
You can make them. It's not hard. Just use a 6mm stud and just tap it and put
it this is what we use. We use this tool to make the push rod. So you just take a 6mm stud, 6mm piece of all thread, and then tap each end of it, and then put a nut on here, and then we use that to make the push rod length we need, okay, as a tool. And then once we get that push rod length, we're going to make a full set onto these cut to fits. So you have these here where they're going to be cut to fit. Okay, so once we come up with our length, we'll make a matching set of chromoly push rods from this cut to fit set we showed you earlier in the other video that had the. So we weren't sure if we were gonna have to do this. We were hoping we weren't gonna have to, but because it does take a lot of time, you know. But you know, it's something that you we can watch this part a couple times over, and you probably get it. Also, J-Bugs has a video on their website, and I think they have their own YouTube, and it shows how to do this a little bit easier. So you can watch theirs. You've watched ours, maybe all that to put together, and you'll be able to figure out how to get yourself through this. And like I said, you can just mock up something. Look, I mean, this is just put on there with these clamps, and you know, the same dial indicator I think we used for the in play, you know, and just kind of clamped it on there to hold it in place. And then you can get this dial indicator at Harbor Freight and do this yourself. It's really not hard to do. So you know, might be a thing to buy. You know, they're not even that expensive over there, and they work pretty good. So anyway, that's how you do the push rod length setup. And then once we get that done, we'll just go ahead and assemble it. We probably won't show us cutting all the individual things. It's just kind of repetitive and long term. But I hope that helps you figure out what you need to do. All right, so we got the push rod tubes on this motor. What's cool is because it didn't require a lot of spacing, it's kind of a little bit of a gamble. You don't always know exactly how much spacing you're going to need. We can use these stock push rod tubes because they're a lot easier to deal with than the others. So you stretch them back. You put your, these are actually silicone, the new ones. I mean, that's the better style. So you stretch them out a little bit. And put them on there. Like I said, then again, these are so much easier to use than the other style. Sometimes you'll end up having to get these spring-loaded ones like this. We have these scat ones, which are probably one of the best ones. They're a little harder to put together. You know, they're spring-loaded, so it's a pain in the butt to put the head on. So fortunately, we don't have to use those. So now we've got our test push rod right here. We've already figured this is our length we need. Because again, to make those again, all you do is just take one of the regular push rod, thread it, put some all thread in there, and put a nut on there to make it so you can set it to place. Tap it, and put all thread in there. And that's how you make that yourself. And then what we're using is one of these. We got two different cutters from Harbor Freight. We got this one, and we bought this style one. We're thinking maybe this one's going to be easier to use because it has a little more leverage, and we really want a nice cut, accurate cut to the right length. So using a tubing cutter is really the way to go, versus using, if you're going to use a hacksaw or something like that, you're going to have to, grind them, hacksaw them longer, and then grind them perfect so that they are perfectly cut. Because we're talking about 30 thousandths thickness that we're going to have to put in our shims. So if you're 10 thousandths off, that's going to make a significant difference. So you need a really good accurate cut on these. So anyway, we're not going to put that all in the video, but we'll bring you guys back in a little bit later and show you guys where we're at. Alright, so we're going to cut these away, show you guys a little bit about how that works so you kind of get that deal. And so we're going to cut one, cut it away. You have to turn it. Keep cutting a little bit. That little cutter just cuts away at it. If you ever use one of these, if you never use one. There it is. A chromoly, it cuts through that pretty quick. I was surprised. These are chromoly push rods, cut to fit. So, and then what you do is you take the ends.
Should make sure they're the right length.
Make sure that's the right length. Check it with this marked one.
Perfect. We'll assemble those in a second.
And then we'll put the ends on in a second. We'll show you. So you take the inside, clean it out with a little file, just to kind of make sure it's no burr inside there. We're just going to heat it up just a little bit. Don't get it too hot. You're not trying to melt it, or, you know, just trying to open up the lifter or the push rod a little bit. And we drop it into a lifter, an old lifter, not your new ones. And then carefully just kind of tap them onto place like that. And then it's a nice press fit. That's how you do it. Let's get putting the heads on. We're going to show you guys how to put these cool tin on here on the other side. So stay tuned for that. And we'll be doing that in the next portion here. See how we're putting these all on. Yeah, we'll probably do a little parts run. Yeah, that's something else we need. And then we'll get this all together. And we got our stuff all shimmed, and so we're just going to go ahead and put the push rods in this side, I think. And then we'll, right now we're torquing the heads. Are they 20?
I'm just doing an initial.
Oh, just doing a small portion torque. Run through and just kind of bring them down slow, because you want your, you know, collapsing your push rods and some of that stuff. So just run through them and kind of just tighten them up a little bit. After we get them all, you know, just kind of get them down so they're snug. Then we start torquing them down. You do like 2 different sets of torques on them. We'll bring you back to the video in just a minute.
Tube just a little bit. Keep making the seal.
Okay. Oh. So we've got the other side off. We just took the cylinder head off the other side. We just did he likes to do like a one tightening on the one side, especially on a mag case. This really makes a difference. We do like partial tightening over here, and then you do like a partial tightening over here, then go back to the other side and do maybe your full tightening or another partial tightening and then another partial tightening. So that especially on a mag case, because they're so not so strong, it just brings it out nice and slow, especially in a brand new motor. I mean, if you have an old one that's been running for a while, you know, you can do one at a time. But when it's brand new, you know, because everything's so tight, you want to make sure that there's not going to be an issue. So we're going to show you how to do cool tin, how to actually install them. I use this thing to punch a hole in the tin. So we're going to punch holes in the tin, and I'll show you what they're for. I'm going to put one right here. One right here. Just 2 on each side. It's a lot faster than drilling. You can drill. It's kind of a neat tool. You have these at Harbor Freight. 40 bucks. So normally underneath your cylinders you have, on your Type 1, you have one of these type of things. And what they have is, on Type 3s, they have this type of a cooling system. And some people will say that this does not make it run cooler, but it actually does. And I'm going to explain this to you real quick. Again, even though I've explained this before, because somebody might be a brand new person watching. So you guys who've already seen this, please be patient for a minute, or you can fast forward a little bit. But what these actually do is they replace those deflector shields. These normally go between the 2 cylinders here underneath the engine. Okay, and the problem with these is they do work, but they miss like this portion right here of the cylinder. So usually when you'll see and right here over here a little bit on this side. So usually what you'll see on an engine, you know, this is the number 3 side too. So usually what you'll see is if you have a bad piston, it's usually going to be burned through right in here, correct? Right here. And so that's right here, or if it was on this one, it'd be right here where the studs are. So what this does is it actually goes underneath the cylinder tin and goes like this. You can just put that on there. We'll just mock it up right now. So they can be a little bit of a challenge, especially with 10mm studs. I think they were designed for 8s. So this case is a little bit thick, so you're gonna have to do sometimes a little bit of trimming to get them to fit. You know, and you can a little bit of bending, so like that. But it does take a little bit of time. So we'll get it on here, and we'll show you what it's like on there. So then through your holes, we actually on this side, you notice we put them on in advance in the back. and twisted them and covered them, because this one here is really covered by the case. And then just make sure they're on there really good and tight. And you put this through your cylinders here, and then run it back through. Let's look at the other side. And then thread them through like that. So it's much easier to do this when you have your engine, if it's out of the car. If it's in the car, it can be really a pain in the butt. And when you're building the engine, it's much easier to do. So these need to be really tightly up against here. I noticed it already popped loose. I'll bring you back in the video in a second. Then you just go ahead and wire them in so that they're on there really nice and tight. Around your studs, around like this, and then so that there's no way they can fall out. You don't want them to get, you don't want any air between the cylinders escaping. It should come, you want everything to come out these metered holes. And so what these do that's better than the other, again, is what they do is, there's two different things. They meter the air that comes through your cylinders. It takes, make sure that all the air is, none of it's wasted. It all has to go through these holes, okay? And what that does is that gives it the maximum amount of, it gives them the maximum amount of cooling, you know, and no wasted air going around your cylinders, so that there's no part of your cylinder that's not getting air. And the second thing that it does is because it meters the proper amount of air going through here, it allows more air to go through your heads, and also helps air to go all the way around the combustion chamber of your head here and go out just this area and go out the back of the car. Now we'll show the cylinder tin on there so you can see what it's kind of more, a little bit what it's like, and then we'll talk a little more about that.
See it.
Okay, so now you can really see what they do when I get down here. You can see it just, there's no, before you would have a gap right here, okay, and you'd have this normal vertical small piece of tin that goes down right here. I would say probably 80% of the cars I've seen that is missing because people took it off and didn't put it back on. You don't totally need that now. So if you can deal with these small holes here, and the back tin on yours will just overlap and set there, and it doesn't bother you, you don't totally need those. You can actually still put them on, but you may have to bend them a little bit, so they're not just going to bolt right on. And you notice it's just like if you get, you know, some of the Chinese tin or some of the, I don't know, Brazilian tin or whatever, and try to put on a German tin, it doesn't fit quite right. You have to kind of tweak everything. You can get them to work, but you don't totally need those anymore. You could actually put nut and washer if you wanted to here, and that'll probably settle it, because what that piece of tin was for, that was here, was to kind of catch some more, so that the air would kind of want to go downward and not just go outward right here, so that you wouldn't have like a bigger gap. That's what that little tin was for, to work with the other deflector plates underneath. So since you have this, now you notice that this goes to the head and brings the air down. They're really, you know, people will say that, you know, that there was a bulletin out on VW, and I don't doubt there wasn't, that Volkswagen said that this kind of tin on a Type 1 won't work. It doesn't help cool it. It's basically, it was an insurance policy for them to not get sued, because if they did say that they did work, then they would basically be saying that their engineering was wrong. And do you think they're ever going to say that? No, they won't say that. So this is how the cool tin are installed, and this is what they do. They're available again at Crankshaft. They're called either Type 3 engine tin, or sometimes they're known as cool tin. Back in the old days, you were called cool tin. Probably just, if you tell them you want Type 3 deflector plates for underneath your cylinders, they'll know what you're talking about. And you can order these. I'll put a link in the video. And it does help cool your engine. It actually, we found that it really does work, give you better temperature if they're installed correctly. And you wire them in like this here. If you don't have the wire and pulling them up tight and they fall loose, that's when people have problems, and that's why people say they don't work. Even some of the old school guys said, yeah, they don't work. One of the guys, Bob Hoover or something like that, says they don't work. And then he says, well, they work only if you install them correctly. Well, when are you going to, you know, when are you going to say that he says they don't work, and the people, you know, and then he says, but they only work if you install them correctly, and nobody installs them correctly. And it's like, okay, well, just install them correctly, then you won't have a problem. So anyway, yeah, we found several degrees of cooler, you know, of cooler temperature, engine to head temperature just from this, and also cylinder temperature lower. I did buy one of those temperature laser things, so we'll be showing some of that later in other videos coming up. I'll be talking to you guys in the next one. And this is going to end this video, but it's also going to continue the engine build. So if you're watching the engine build, stay tuned. This is going to end this particular portion of the video, because we're going to put this up separately. Alright, so we're going to put in the pushrod tubes.
Just put a light coat.
Yeah, we're going to put some of this, put the wonderful brown goop. I hope you guys enjoy using that stuff. Because I don't.
I love it. It smells like sawdust.
Yeah, it's just like, I don't know. I used to put them in dry years ago. But I guess this works too. Hang on, this one's bent. Yeah, it's our tin just works great.
What they do is they take a push rod, hold it in place.
Yeah, you just use a push rod, drop it in the hole.
Yep. Just do one by one by one.
Hit them with the brown stuff again. Ooh.
Just a little bit.
Yeah. Stick it in the hole. Drop in the push rod. Good old brown. Stuff. This is, make sure this is like the number 2 that doesn't dry. The number 1, I think, is the stuff that dries.
This is the format gasket aviation.
Yeah, aviation format gasket. Permatex sells it. You know.
Sticky and gross, but it seals
cheap.
up pretty good. What I normally do,
I think it's very expensive to
we'll
buy.
we'll take a brand new container and we'll leave it cracked open for a week, so it thickens up.
Yeah.
This stuff's like piss water, man. It's terrible.
Yeah, that stuff's.
But when you thicken it up, though, it actually works very.
Yeah,
well.
this stuff's really thin. I'm used to it thicker too. I think all mine are so old that.
Yeah, and those are the best ones.
Those are the ones I had. You know, like I used to have when it was like 10 years old. It lasts forever.
Oh, yeah.
And but you know, then I didn't do VWs for a while, so I didn't keep that around. I probably chucked it at some point. Don't remember. You just drop your heads in.
So then make sure after we get everything here, we
kind of play around with it, make sure that they. That's why these are a lot easier to do than the spring-loaded ones are a real pain. So if you can get your motor specs just right, like we were really fortunate with that. If you go with the same parts that we have on this video, you probably will be pretty close to where we at within, you know, 10 or 20 thousandths. So who knows?
All right, make sure you got all the seams facing upwards too, because that'll keep them from leaking if they start to go bad.
Yeah, and then again, we are 5 thousandths off one side to the other, and we're not worried about that. Some guys will get freaked out about that. Oh my God, you should have had the block deck, all this stuff. We're not racing. This is just an engine to drive, and it really won't make that much difference in the total compression or CECCs. So yeah, you just set them in there that way, and then what's the next step? All right, so then we just put the brown crap again and run all the ones on the inside of the valve cover. Of course, these side are the air side. Really, no need to put the brown stuff over here. It's not really doesn't really lock the threads or anything like that. We're just, you know, it's mainly just to, in case around that, you know, there might be some leakage or something.
You can get a drip. You
can get a very small oil leak from that. You know, who wants any oil leaks, right? Is that the whole idea? And you just run them down, run through them, you know, just get them snug. Just don't even get them really snug. Just start to bring them down little by little and just kind of work your head down. You know, you are collapsing the push rod tubes as you go. Because remember, earlier I stretched them and put the things on them there and twist them a little bit, check them. You know, make sure they're not like going crooked. You want to make sure that they don't, you know, do any of that stuff. If you got a crooked pushrod tube, what'll happen is your pushrod will actually rub against it. So
what I do is just get a ratchet end also.
Yeah.
And just kind of.
You can do that to them.
Pull them around a little bit to kind of center them up.
Make sure they're centered. You do not want one that's crooked.
Because the edge of it can rub on the pushrod.
Yep.
And damage that.
Well, it'll damage the push, not just damage the pushrod, but it'll cause a leak. You know, it'll actually rub through. They're very thin metal. So, anyway, that's pretty much it for that portion. I think we'll bring you guys back in a little bit later. Yeah, I would say, you know, use your book and your torque specs from your book for your heads. Remember, this is an aluminum case, so probably the highest amount of torque that they would allow, you know, would be probably okay. And make sure you do it to the normal, you know, whatever it is. I think it's, what, 24 pounds to, you know, something like that.
23 for the heads for
yeah.
10 millimeters and 18 for the 8 millimeters, but I always do 24 on the tons.
You can do 24 on the heads, no problem. It's an aluminum case. We're engineered different than the original, so you don't really need more than that, though. People think they want to tighten it more, but there's no real necessary need. All right, so I'll bring you guys back in the video a little bit later, and we will check that out when we get to the valve adjustment. All right, since we have the chromoly push rods in here, this is how we normally do it, and you can do whatever you want. If you don't want to put them at that, you can put them at 6,000s, but I'm going to tell you, if you put them at 6, you're going to have a really noisy motor. It's going to be clacky like crazy because the chromoly push rods make a really loud clacking noise. So, because they don't have the same resistance that or they don't have the same, you know, expansion contraction of the aluminum, and so they actually work fine, we found, if you put them at 0, which there's a way to do that, or some guys run them at 2,000s. So you can decide what you want to do, but what we do is we tighten it down. Wait, is this one ready?
Either or.
Oh, what's that?
Either one.
Yeah. So we tighten it down here, and you'll feel it you'll feel a little bit of like movement. Okay, you tighten a little bit more, and all of a sudden you'll feel it to where it just stops, and there's no movement. But you can also still freely twist the push rod around. So you feel here, you feel it's like there's some, you can get that push rod to spin really easily. Then that's I don't think you can see it, but anyway, you can make sure that push rod's spinning, and then tighten it right there, and then double check it. Again, like I said, that's preference. This is a preference thing. If you run them at 6, it's going to be super noisy. You know, the typical is 6,000s, and then we do them, tighten them up, check them, make sure they spin, you know, and make sure they spin freely, very freely. So it's almost, because a 2,000s feeler gauge is so thin, it's like a wafer, you know, so it's almost like you could do a feel, and you'd probably be about the same place you were, about 2,000s. So running them at 6 is just like I've done it before, and it's just like really noisy, just clacky. And he's got the fancy tool. You can see that. You can do this with a wrench, though. You don't need to have that. Just a regular wrench and a screwdriver. But this here, you know, has a screwdriver and a wrench all together. You can see the screwdriver inside. Pretty cool. All right. So anyway, I think that's going to wrap it up for this video on this portion. Remember, the next one's going to be very important too. A lot of people are going to go, oh, I can dress my motor, I can put all the tin on it. Yeah, okay, but there's certain things that you have to do. Like, one of the things you have to do is you have to put on a breather kit. If you run anything larger than a 1776, and even some of those, if you're running really high RPMs, they need a breather kit. So we're going to put on the breather kit. We're going to show you what that is. We're going to have, and we're going to show you how to set up the oil cooler and all that stuff, and the oil filter, and also the extra sump. Oh, I forgot to get the we need longer studs for the extra oil sump. So So we still have that to do. That'll be in the next video, and we're going to go ahead and wrap this one up on this. And we're still sandblasting our valve covers, but we'll go ahead and put those on as soon as we get those done and cleaned and painted. And we want to keep it clean over the weekend and let you guys check all this stuff out. Well, I'll talk to you guys in the next video. Please like, share, and subscribe, and we'll see you when we're done.